TrailBlazer. I'm David Mitchell,
And I'm Aaron Cook.
and we're going to walk you through a C# and DotSpatial program that we developed for CE 594R Geoinformatics, taught by Professor Dan Ames at Brigham Young University. The requirements of this project was to create a standalone desktop GIS-enabled application that allows a common user to select a digital elevation model and a trail shapefile, or create one of their own, and plot the longitudinal elevation gains and drops and compute statistics related to the difficulty or ease of the trail. Alright, when the user first opens up our program, this window will be generated. The first thing that we advise a user to do is to set their units. So you go Home, Set Units. Now the user will need to know what units their digital elevation model that they wish to use in our program, what units those are, and import them here. Or they can import their own. However, all units will be measured in whatever the digital elevation model is. So for demonstration purposes, we're going to use the Ames unit of measurement. And unit for elevation, we're going to use Dan. Now it says that the units for distance are set in Ames and elevation are set in Dan. Next thing we're going to do is we're going to add a digital elevation model. For demonstration purposes, we're going to add iron.dgb. However, we also have a digital elevation model that we provide to all of our users for Salt Lake County and Utah County in Utah. The first thing that the user will need to do is select the iron DEM file and click Layers, then use selected DEM layer for analysis. And it says your selected DEM layer is now ready for analysis. Should this not be a DEM, it will warn the user saying that this cannot be used as the DEM file for analysis. It also does the same for the route layer, as demonstrated here. Next thing the user will need to do is add a layer corresponding to the trail. We have provided our users with a map of the Jordan River Parkway Trail in Salt Lake County, as well as the Stewart Falls Trail in Utah County. However, this program also enables users to create their own path. And this is done by clicking on New Shapefile, selecting Line, and then clicking Add Shape. Now the user simply needs to click within the digital elevation model at random points, or points that they wish to travel, right click and say Finish Shape. Congratulations, you have now created your own path. Next thing you need to do is select New Layer, click Layers, and use selected route layer for analysis. Congratulations, you have a path layer ready for analysis. Now, to be entirely certain that all variables are defined prior to analysis, you click Layers and say, Are we ready for analysis? It says, You are ready for analysis. Let's analyze, baby. Go to Analysis, Perform Elevation Analysis. We're now going to turn the time over to Aaron Cook to explain the analysis functions.
Thanks, Dave. Yeah, so we're ready for analysis. Let's go analyze something. So now we've got both the route and the DEM ready. We've got both the gradient map and the statistics page ready to receive the analysis output. So now we click Perform Elevation Analysis, and it will switch right over to the gradient map. Here we have an elevation along a map curve. So we've got our distances here, measured in Ames, and our elevations here, measured in DANs, as we've already set our units up here. So then it'll follow along, and you can see that here you've got this first segment that has a fairly high elevation, it comes down, and then you've got this segment here that's a valley and then comes back up. And so on the gradient map, you can see that on the same here. And then finally we have our statistics, which gives us our max slope in percent, our min slope in percent, and then the worst slope, because sometimes the min slope is negative and max slope is positive, and so we want to know our absolute worst slope. Then it also tells us our max elevation and our units, and our min elevation and our units, and also the total distance of the path. There's one other handy feature we have that are extensions. We can have an extension where we show a base map plugin, where the user can select between several base maps, which will show behind the the map. We aren't going to load it because it takes a little bit of time to download all that data. And we also have a few help functions with about and the end user license agreement over here. So this just makes sure that we let you know how to use our program and how to use it legally.
Thanks, Aaron, for that educational demonstration. Now that you know the legal sense of our program, we'll now walk you through our code. This code incorporates the MIT license as defined right here. We also want to make a shout out for our icon, because our hiker icon that we use for this program is licensed under a Creative Commons attribution and must be attributed as hiker by Les Vieux Garçons from the Noun Project. Thanks, Les Vieux Garçons, for this wonderful icon. The first thing that we do is we set a series of references that will be used in the program. The next thing we do is we create a container in our main form that can hold all of our other controls. These will be used for our extensions and add-ons that we use throughout the entirety of the project. The next thing we do is we define a set of variables for use throughout the project. The next thing we're going to do is initialize all of the components, and also involves a container control so the plugins know where they can put themselves. And we add all of the extensions. And the extensions can be seen here. We have a base map, all of the DotSpatial controls, and all of the form controls that are used throughout the entire project. The next thing that we do is we create the plot function. This is basically the plot of elevation that you saw earlier. And the next function that we create is what happens when the form loads. This is a rather lengthy function. The first thing that we do is we create a series of root items. This is basically the menu that will be displayed at the top of our program that holds all of our buttons for analysis, adding layers, etc. The first thing that we do is we create the home button. Now the extension is looking for a variable called khome, so we were required to use that in order to add the functionality of being able to save and open various items associated with our project. We also threw in a feature called setUnit. This is where the user is able to set the units that will be used throughout the entire analysis. We also create the layers button with the drop-down items to add the layer, remove the layer, use selected DEM layer for analysis, use selected route layer for analysis, and are we ready for analysis? The next button, pull-down menu, that we have is the Analyze. And within that we have Are we ready for analysis and Perform elevation analysis. The next menu that we have is the Help. And nested within Help is the About TrailBlazer and the End User License Agreement, as well as the Panic button. Next thing we do is we have the extensions. This allows the user to activate or deactivate the basemap plugin, which the code to do that is here. And at the bottom right hand corner of our map, we have the XY coordinates that are used throughout the entire program. This is how we give real estate for that.
So once we've taken care of the menu items, we look at what happens when someone looks at the basemap plugin button. And as they click on the basemap button, it will call the webmap plugin and activate it if it's deactivated, and deactivate it if it isn't. When they click on the end user agreement button, it calls up that form. When they click on the About button, it shows this message box, and when they click on Panic, it shows the Panic message box. once someone clicks on the Set Units button, there's a separate form that we have that you've already seen how it looks like, and it just basically sets two global variables that we have set in distance units and height units. And also, on the statistics page, it will change the labels of the distance and the elevations. You remember the parts where it had Dan and Ames names, is where it had this set, or that was where that magic happened. If someone clicks on the Add Layer button, it calls the Add Layer function. If someone clicks on the Select EM, it calls this function, which it tries to see if it's a raster, and if it's not a raster, then it will say, "Hey you, this isn't a DM," because DMs need to be rasters, at least in our program. So if someone does the select route, it's very similar, only it's a line layer rather than a raster layer, and then it checks against. If they click on selected, it will try and remove it unless it's equal to the DEM or line layer, and it will complain that it needs either one of those for the analysis. If the user wants to determine all the variables present, or if the variables are present or not, it checks to see if there's a defined DEM layer and a path layer, and if both of them are not null, in other words there's something in them, then it will say you're ready. If not, it will provide an equivalent error message. If the user wants to determine if it's all available to perform elevation, it's the same as above, but for some reason the menu needed to have two subroutines to have it in two separate locations, because there's both in the layers and the analysis menu. So if the user clicks on the button to run the elevation analysis, it calls the subroutine that we've written called show elevation, and that's later in our code. And it shows the elevation tab, and then it runs that analysis. So then this function is defining the get elevation as a raster and coordinate, or as it's passed in a raster and a coordinate, and it finds what the coordinate is of each part of the path, and then it finds the elevation for that and it returns the elevation at that point. As you get the distance between points is another subroutine that we use. It's basically just the Pythagorean theorem distance. Then it generates the list of coordinates needed for the analysis. You get coordinates from a line, and so it sets the line up. It goes through every single point, and it figures out if the point is too far away from the last one, and it'll add points in between as well to find those distances in between here and in this next subroutine. So, and then it will return a list of points that it's already defined as all of the different points along the route. This will be passed into the find elevation and create a whole list of elevations to be plotted along with the points and distances. So when it does show elevation, if there aren't any raster layers, it asks to add a DM layer, and if there aren't any line layers, it asks to add a path layer. And then it tries to put together all of these lists that we've been working towards already, with the elevation list, the distances list, and the slopes list, which are used later for the analysis. Then it gets all the distances, and then it has a total distance variable as well, which is a global variable, so that it can be called in different places and different forms. The start elevation and end elevation are both set at 0, so that it's got some value in case they don't have data and for some reason it calls. There's something there. And then it initializes the start elevation and end elevation for each segment for the slope, and then it will find out what the slope is by just taking the rise over run distance by end elevation minus start elevation divided by that section's distance. Once that's all taken care of, it'll assign the global variables of low elevation, high elevation, maximum slope, and minimum slope, and then perform logic to assign all of those statistics to the statistics page. And then it'll just catch any exceptions, especially if there's a path outside of the DEM, it'll catch that. And then this last part is where the magic happens for the XY coordinates at the lower right. And then this is what happens when the map loads its main form and it doesn't do anything. But it's still there because we like it. The set units form just sets, it asks for the two inputs once people click on OK. And it sets the variables, the global variables for distance and height units. In these global variables, it's just a really, really simple subroutine where there's all of the public units and default values for each, so that if there's ever a time that they're called, then it will tell them what to do with distances and all that to set distances. This has been our project. Thanks for watching.